Good day, everyone. Today we'll be doing a packet tracer activity entitled Point-to-Point Single Area OSPFv2 Configuration. This is packet tracer activity 2.2.13 under the Enterprise Networking, Security and Automation CCNAv7 ENSA course. And so, let's open our packet tracer file.
Of course, don't forget to log in with your profile.
Alright, so let me just put this instruction aside on this side of our screen. Okay, so looking at our packet tracer activity, we are given this logical topology with three routers, R1, R2, and R3, in which each has a link or one link with each of the other two routers, and whereby each router also connects to their local area networks. R1 connects to a LAN 1, R2 for LAN 2, and R3 for LAN 3. Okay, we also have these switches and the three PCs. Let's take a look at the instruction. Okay. This document gives us the addressing table of all the three routers and their interfaces, IP addresses, and subnet masks. So for R1, R2, and R3. This also gives us the IP addresses and subnet masks of each of the PCs. So you notice the PCs doesn't have their labels, but this actually is PC1 and it belongs under LAN 1 through R1, and this one is PC2, and this one on the right is PC3, right? Okay, so let's scroll down to our manual and to know what are the objectives of this activity. So this activity is divided into four parts, and we are to first configure the router IDs, then configure networks for OSPF routing, then configure passive interfaces, and finally verify the configurations that we just did. Yes, this activity will activate OSPF routing using network statements and wildcard mask. This would also configure OSPF routing on interfaces and by using network statements quad 0 masks. So which means we'll be trying out three ways on how to activate OSPF in a network. In addition, we'll also be configuring explicit router IDs and passive interfaces. So let's proceed to part 1, and that is configure router IDs. To start the OSPF routing process, of course, we have to activate or enable OSPF by typing in router OSPF and then the process ID. As stated, we are to use process ID 10. And then we should also be assigning router IDs such as router 1 to have 1.1.1.1, router 2 to have the router ID 2.2.2.2, and router 3 for 3.3.3.3. Okay, so let's begin with router 1, of course. Okay, so let me just put that on one side. Okay, of course, we are in the user exit mode. So we have to go to the privilege exit mode and of course the global configuration mode. Okay, so from here we need to activate OSPF by typing in router OSPF and the process ID 10. Okay, now when we have the OSPF enabled, we can now assign a router ID. So for router 1, router-id, so that's the command, followed by the ID specified, which is 1.1.1. Okay, and then press enter. So we're done with router 1. So let's do the same for R2. Okay, so let me just display this one. So for R2, okay, router OSPF process ID is also 10, router dash ID 2.2.2.2. Okay, alright, so let's do the same for router 3. Okay, router activity. Okay, for router 3, router OSPF process ID 10. Okay, router dash ID. For the third one, it's 3.3.3.3. Okay, alright. So we're done with part 1, and continuing to part 2, we have the following steps. Okay, but before going to instruction letter A under step 1, we need to answer the following questions first. How many statements are required to configure OSPF to route all the networks attached to router 1? So actually this is router 1, and we see that there are 3 interfaces which is connected to other 3 networks. So the question, how many statements should we use to configure OSPF to all 3 attached networks? Of course, the answer is 3. So don't forget to write that on your manual, which you'll be submitting together with your accomplished packet tracer activity on our Open LMS. Alright, so let's proceed to the next question. The LAN attached to router R1 has a /24 mask. What is the equivalent of this mask in dotted decimal representation? So of course, we know that a subnet mask represents all the logic ones on our network, which specifies the network ID and the host ID. So the question, what's the equivalent of a /24? So that actually gives us a dotted decimal value of 255, sorry, dot 255.255.0. Why? Because a /24 completes the third octet with logic ones, thereby leaving the last octet or the last 8 bits to be zeros or to be the host portion. So this is the subnet mask for a /24. So let's continue with the next question. Subtract the dotted decimal subnet mask from 255.255.255.255. So if we do the subtraction, so let me do that here. So of course, 255 minus 255, it's 0.0.0.255. So this is what we call the wildcard mask, right? Okay, next question again is, alright. What is the dotted decimal equivalent of the /30 subnet mask? So we know if it's a /30, so we're left with just two portions or 2 bits of the host portion. So we have 255, the 255, the 255. That, how many? You just subtract 2 bits, so that's 252. Because the last least significant bit is a 1, the second one is a 2. So if we add that, that's a 1 and a 2. So we subtract it from 255. So this gives us 252. Right? Okay, so we still have other questions. Now, subtract the dotted decimal representation of the /30 mask from, again, 255.255.255.255. So the result should be 0.0.0-3. Right, so this would be the wildcard mask for all the interfaces or the networks which has a /30 subnet mask, and then this would be the wildcard mask for those networks with a subnet mask of /24. Alright, so let's move on now to step A. Okay, So let's configure the routing process on R1 with the network statements and wildcard masks that are required to activate OSPF routing for all the attached networks. So we'll be using the network addresses. So the network statement value should be the network or the subnet address of the configured network. So our syntax for that or the command is network and then specify the network IP address and then the wildcard mask, type in area and then the area ID. So by default, the area ID we are using is always 0. So we'll be using area 0. Okay, so for R1, all right. Okay, we'll be configuring all networks connected to R1. So we begin with the first net. So again, how many networks are there with R1? So this is the first network, the second network connected, and the third network connected. So we need to have that network address and the subnet mask. Network address and then the subnet mask. So R1. All right. So to do that, we type in network, okay, and then the IP address. So that's 192. We can, if we take a pic on that, that's 192.168.10.0. So let's that 10.0, and the subnet mask for that is actually /24. So we will be using the wildcard mask rather. So that's 0.0.0.255, right? And area is always a 0, right? So that's for the first network. So we have to do the same for the other two networks connected. So we type in again network, and then if we look at the other network connected, that's actually 10.1.1.0/30. Okay, so that's 10.1.1.0, right? And the wildcard mask is 0.0.0.3, and area is always 0, right? So, and then the last one is, the last network is 10.1.1.4, also a /30. So we just need to change 0 to 4. So let us just get from the command history. So that's a 4 in same wildcard mask, same area, and then we press enter. All right. So we're done with the OSPF configurations of all the three networks connected to R1. So let's verify if we just did that configuration by typing in show run. All right. Okay. Okay. So here you go. For the router OSPF10, we also did the router ID a while ago. So these are the networks. Okay. So I'm sure you can double check if we did the IP addresses right. Okay, so we're done with R1. So now let's proceed to R2. Okay, and going back to the instruction, so that actually is step 2 already, right? Step 2, we configure networks for OSPF routing, this time using the interface IP addresses and quad 0 mask. So that is what we'll be doing for the second router, right? So the syntax is actually the same as what we did with R1. So we type in network, the IP addresses, this time, instead of the IP address of the network, this would be the IP address of the interface. And instead of using the wildcard mask, we'll be using the quad 0 mask. So that's the default wildcard mask use. And then for the area, still, we'll be using the default area 0, right? So let's continue for R2. So we type in network. Okay, so let's take a look at our R2. So this is our R2, And if we are to look at the interfaces, actually, what is the IP address of these interfaces? So this one, and this one. Of course, these are the network addresses, right? So the addressing table we have on top of the manual might be helpful because this is actually the IP addresses of the interfaces, right? So we'll be getting this IP address. So we'll start with 192.168.20.1, all right? And we'll be using the default or the quad zero mask. So we'll have 0.0.0.0 and then area 0, right? Press enter. We do it for the next two interfaces. So
That's 10, that one, that one, that two. 0, that's 0, that's 0, that's 0. Area 0. Press enter. For the last one, we'll just change 1, that 1, that 2 to 9. Oh, sorry, only that. Right, so let me do that again. So this should be 9. 9, 1, 0, and then area 0.
right, so we're done with this one. So let's show run to see or verify the configuration. Alright, so this time the OSPF has the following addresses configuration. Okay, so we're done with the second router. So let's proceed to the third router. Okay, and that's under step 3. Okay, so we'll be configuring OSPF routing on router interfaces. So which means we're not using any IP address, but we'll be using or we'll be configuring through the interfaces. So looking at our router, for example, router 1, so the interfaces that are used to connect to the networks are the following. Right, let me check. So this is serial 010. This is gigabit Ethernet 0/0/0. And the last one is serial 0/1/1. Alright, so that would be what we'll be using for R3. Alright, so enable. Okay. So this time for router 3, we have to go through the interfaces, each of the interfaces. So from our previous command where we assigned a router ID, so we need to go and exit, go to the global configuration mode and enter into the interface. So take note the interfaces are gigabit Ethernet 0/0/0 and serial Ethernet 010 and 011. So let's go first to the GI interface, gigabit interface. So we type in interface 0/0/0. Okay, and when we are in the interface, that's when we assign IP OSPF 10 area 0. So here we are specifying on this interface that this would be an OSPF with a process ID 10 and an area of 0. So enter lang po. Okay, we do the same for the other two serial interfaces. So let's get to serial interfaces 0/1/1. Okay, type the same IP OSPF 10 area 0. And then we go to the other interface, which is 010. Press enter, and then IP OSPF 10 area 0 and press enter. Okay, so now let's take a look at the configuration. Okay, sorry. Okay, so where is it configured now? All right. Okay, so the interfaces have the configuration IPOSPF10 area 0. So serial interface, another serial interface, and the gigabit interface is where? This one. Okay, so there you go. We have the OSPF activation on all three interfaces, right? Okay. Next step would be okay, part 3. Okay, so we're now on part 3. Notice that the completion is already at 83%. Okay, OSPF will send protocol traffic out of all the interfaces which are participating in the OSPF process, but the links which are not configured to other networks such as the local area networks or our LANs, this unnecessary traffic consumes resources. So what we'll be doing is to prevent the OSPF process from sending unnecessary routing protocol traffic through these LAN interfaces. So, which LAN interfaces has R1, R2, and R3 through LANs? So, this is the, what interface would this be? So, this is actually, sorry, this is gigabit interface 000. This one, which R2, which connect to R2 is LAN 2 is also 000. Interface which connects R3 to LAN 3 is also 000. So we have to okay, we have to configure these passive interfaces. Alright? Okay, so how do we do that? We again go to each of the routers. Okay, okay. And then go to router OSPF process ID 10. So when you're inside the router interface, you just type in passive dash interface and then the interface number. So that's G000. Okay. Okay. So that's it for router 1. Okay. So we do the same for router 2 again.
We're still on the router interface, so we can just type in passive interface, gigabit, ethernet, interface, 0/0/0. Right? So finally, for all three, so that's, we are in the interface, so we need to exit and go to router OSPF 10. Okay, and passive dash interface, then 0/0. Okay,
Right? Okay, so let's look at the instructions next. Okay. Okay, we're done with part 3. Part 4 will just be verifying the OSPF configurations we just did by using the show command. So we'll be using the show running configuration command. So let's begin with, of course, R1 first. So R1, let's show run. So let's check. So we have this configuration, okay, with the passive interface. All right, so complete. For R2, we can also do show run. Okay, and let's check. Alright, okay. For this configuration, also complete because we have the passive interface gigabit Ethernet. Okay, and then the last one, to show run. Alright, okay. So for this one, the interfaces has its individual OSPF configuration, while the OSPF summary tells us we have the passive interface for gigabit Ethernet 0/0/0. Right? That's it. We have completed our packet tracer activity. Point-to-point single area OSPF v2 configuration. Don't forget to save your accomplished packet tracer file and your answered manual saved as a Word document and submit in our OpenLMS assignment. That's it. Bye.